Okay, good afternoon, everyone. Thank you very much. Huge honour to be here and speak to you. And I think, let's just take a moment and pause on what the last 15 years has led to, the fact that we're all here discussing CHERI. But I think it's fair to say, we're the converts, and that's why we're here. So what I want to talk to you about today is, how we actually get this to the global scale that ultimately we actually want to. And the problem that we have here is not a technology one anymore, really. It is now about how we articulate the value and measure that value that CHERI brings to the world, and especially to cybersecurity. So for those that don't know, National Cybersecurity Centre, part of GCHQ, our mission in life is to make the UK the safest place to live and work online. We're also the National Technical Authority for Cybersecurity. Let's see if I can make the slides work. Okay, so when we've achieved our aims, we will be able to do these three things for CHERI. So the first is we will be able to quantify the returns to the companies that have implemented CHERI in their products. The second is we will be able to evidence that there is no better scaled solution to the memory safety problem. And then the third is that we can quantify to a typical code base, to a typical product that is maybe legacy in part, how much it costs to adopt, and then we are relentlessly able to reduce that cost of adoption over the next kind of half decade or more. Because these are the things that leaders that make strategic decisions about technology are going to want answers to before they put CHERI-enabled products on their product roadmaps. And unfortunately, these are the hurdles that we're going to collectively have to overcome if we want to get where we want to get to. So I'm going to run through what the strategic imperative is. Then I'll go through kind of breaking down actually when we think about quantifying value, what that looks like in practice. I'll highlight some barriers where some smart brains in this room will be able to kind of collectively help, and then kind of outline a future that we're ultimately aiming for before going into some closing. So I don't think it's going to surprise anyone that there is a strategic imperative. The latent memory safety vulnerabilities that we know about continues to grow year on year, and that's for a multitude of reasons. Fuzzing has got better, and we are on the cusp of artificial intelligence applied at scale, which is going to surface an absolute bow wave of vulnerability that has existed in code bases for many years, if not decades, that we're going to have to contend with. So what we know about memory safety and the vulnerability it poses only continues to grow year on year, yet somehow we are not able to make the strategic interventions which are necessary to address that at corresponding scale. So when we look at what the aftermath of that is in reality, it's very hard to sit here as the CTO of the National Cybersecurity Centre and realise that we have edge security products being sold by vendors in 2026 that have exactly the class of vulnerability that CHERI is kind of designed to mitigate, not only suffering the class of vulnerability, but adversaries are finding them and exploiting them to enact and exact massive cost on countries, be it economically, criminally, or otherwise. And, it feels like you're in an alternative reality sometimes when you sit inside the NCSC. We can see the evidence. We know that there is a massive problem. Vendors will acknowledge that that problem exists. And yet we have credible solutions like CHERI, which are not being adopted at the scale and pace that we would suggest is necessary. And we have to ask ourselves why that is. And obviously, it continues to be a gift on giving. So we have had vulnerabilities that have been floating around for 3 decades, which are only being found in the last 10 days or so, again, which CHERI would have mitigated. So I think it's quite clear, why, even just looking at that, why we need CHERI and why we need CHERI at scale in every product. And then you look to the future and then you realize why we really need it. So if any of you have been to Asia recently, you will have seen robotics are commonplace now in restaurants and similar. We now have at least 3 robotics companies valued over $1 billion. There's an awful lot of money flooding in when we think of embodied AI. this is coming, and this is going to come at a degree of scale. We've already seen at least 4 examples of memory safety vulnerabilities being exploited in various consumer robotics platforms, from Hoovers to robot dogs and similar, all with the predictable consequences that we would all know, that if you've got things which are mobile, which can be driven around and have cameras and microphones, inevitably the outcomes that you would expect to manifest. So how do we learn and ensure that the manufacturers of these devices are not putting non-CHERI enabled hardware into their devices from the get-go? Why do we have to repeat the doom loop? So again, the strategic imperative. So we have some time to avert the inevitable there, but we do not have limitless. And so that leads us to our set of challenges. So the strategic imperative really is that we need to make sure that CHERI is across the whole suite of silicon that we would expect. I think, naturally we've seen early adoption in the first 2 of these, but as we kind of go on and at pace now, as we go into the accelerators space, again, we're seeing some positive signs, but then into general application cores, it is going to be important that we have silicon which is available to a vast suite of device manufacturers across all 4 of these, arguably in years and not half decades. So when we look at quantifying the value, we need to be able to explain to a company that has invested and potentially paid 3x on their bill of materials to get a CHERI equivalent into their device, what is their competitive edge. And at the moment, today, this is one of the fundamental challenges that we have in technology, in that there are lots of technologies which are fundamentally running memory unsafe products. They have vulnerabilities in, those vulnerabilities are being exploited, and the market does not seem to penalize them. So at the moment, you have the deeply diligent company who is investing and the deeply kind of negligent company, and yet there is no market reaction to that. And we have to address that some way. There has to be a benefit to be the company that does the right thing. There is naturally going to be an increased velocity. If you do not have to worry about, in the same way that you have eradicated every memory safety vulnerability in your product because you know it's not going to come back to bite you, your developers will naturally be able to write and ship code at a far quicker pace. That is material. So how we are able to quantify the patches that didn't need to be written, or the testing that doesn't need to be done necessarily in the same way because there are other safeguards intrinsic to the platform, be it the compartmentalization or the memory safety, are indeed really, really powerful. There will be a human capital cost saving here. There will be roles which are not as necessarily important. Like I've run static analysis in large technology companies, and just the developer time that is consumed dealing with all the false positives, because we're running a C code base, we had to do static analysis, that produced loads of false positives. There's a huge effort saving here, and again, we need to be able to quantify some of that. We saw some of the beginnings of that in Robert's presentations. The patches that never were. And this is where it's going to be really interesting with the Cyber Resilience Act in Europe, which has introduced product liability and the need to release patches to security vulnerabilities. There is a very easy way here to start to measure a product that does have CHERI and a product that does not have CHERI, and the cost differential as a vendor that has to sustain it through its usable life. And that is going to be extremely compelling to a lot of vendors that are staring down the barrel of the liability that comes from the CRA. And then there's naturally the kind of the counter argument that we're going to have to deal with. Why don't we just re-platform into Rust or some other memory safe language? And actually, for a lot of code bases which are deeply complex, which may still, even if they're in part written in memory safe languages, will be written in memory unsafe languages, it is just not practical for a whole host of reasons. And if you were, the prices would be, the cost would be extraordinary. So how we deal and quantify what that variance is will be extremely important. Then to the vendor, how they deal with their technical debt. There are lots of companies that know that they have a 30-year-old code base that's written in C, and that they've touched about 8% of it in the last 4 years, and there's lots of it that they haven't. And they just don't know how to deal with that credibly at the moment. They just hope someone doesn't find it, and hope is not a strategy. But actually, when we think about compartmentalization and the memory safety value of CHERI, you can say actually you can carry that risk and it doesn't become a millstone around your neck. And it naturally gives us an extended life of products that would otherwise potentially have to be refreshed. And that's so it's both valuable to their customers as well as the vendors. So customers, especially in the critical national infrastructure space, are really wrestling with this problem at the moment. They've got a generation of products that were not designed for the contemporary era of exploitation. Actually, as they refresh, if they know that they can get 10, 20, 30, 40-year usable life out of that, that becomes a very valuable differentiation. And then we should recognize the compartmentalization saves us from the supply chain attacks. And again, the supply chain attacks are relentless. It feels like that they are bi-daily at the moment in some guise or other. XZ was such a near miss that we had as an industry because of one diligent individual that loved their performance modeling, like they did their butterfly collection, detected that someone had done that. But again, people do not understand that CHERI could have mitigated that had it actually hit effective products and solutions if implemented. And then for the insurers, how we are able to talk about how the impact would have been reduced from a breach, from a vulnerability. We talk a lot about blast impact minimization. And so, this is going to be extremely important about how we think about how we articulate this in a meaningful sense. And then we talk about the compliance. And compliance is a great business forcing function. CRA is the beginning of that in embedded products. There will be more globally. Countries, governments, regulators have realized now that they're going to have to move to regulation and legislation in order to force products to be of sufficient quality. So actually, how do we show how CHERI-enabled solutions satisfy those demands in a way which is more cost-effective than other options available to the vendors and the customers? And then ultimately, we get to the stage where we have some interesting test cases going through the US system at the moment around liability because of vulnerability. Depending on where they land, that could set quite a watershed moment for businesses where they will deeply care about what their liability is for insecure technology and then how they ultimately want to manage that. So we should also recognize that there are some quite key barriers here that we haven't necessarily got the answers to. So firstly, and often one that we run into as government is the null hypothesis. If I do nothing, how is it better or worse from this point? And so we have to appreciate that there is naturally a degree of apathy that we're going to have to overcome. So the case has to be compelling for CHERI, because actually a few degrees of improvement is probably not sufficient to move those people. And again, we hear that a lot in bill of material costs, but there will be other barriers. So what is it that is going to incentivize the lead engineer, the product manager, the chief exec, the chief financial officer to really go through either a re-platforming effort for an existing product or a platform, kind of a new platform for a new product and the retooling that's going to be required. And so we have to worry about that. The second is the incentives. And we've got some massive problems in technology more generally. If you work on your typical executive is remunerated on a 3-year performance cycle, and that performance cycle is generally dictated by revenue growth and profitability, that's their incentive. Those are the intrinsic incentives here. So how we actually bring kind of the value of CHERI to enable and for them to understand actually what they're incentivized by, it will accelerate for a whole host of reasons, is going to be one of those very interesting hurdles that we inevitably have to overcome. We don't have a lot of transparency in technology, and this is something that as NCSC that we're trying to address. So at the moment, you don't know really beyond the superficial, maybe a bill of materials, software bill of materials, actually what a technology stack is constituted of. So you don't know how much of it is written in a memory unsafe language. You don't know how old that code base is. You don't know the provenance of that code base. You maybe know what third-party libraries you used and their version numbers. We work on a hypothesis that if there is greater transparency in technology, the buying community will make better decisions. And one way we describe this is we know more about that's in our sausages than in our software, but it does translate, right? And that feels a bit of an odd place to be in 2026. So how we drive greater transparency in technology so we can really surface up the problems and the scale of the challenge that we know organizations are going to need to address will be one of those barriers. Availability, you've got whole sessions on this. We need to be able to get the products into people's hands, and that's kind of everyone from the small, medium enterprise, the entrepreneurs who are building the next generation of products, who today might be using a Raspberry Pi as their base platform as they start to kind of spin up, all the way through to those who are established players and they just want to pick the right chip to place on that board. Unless we can solve the availability problem in a meaningful way, it is going to be the domain of the few. And that's going to limit our growth opportunities here. So how we enable that access to all parts, so be it the tinkerer or be it the large product company. Bill of material costs, it's going to kill us, right? And so I've already had discussions with some in the room since I've been here, kind of who have been lobbying. I think it's probably fair to say quite strongly that this is one of the areas that we do need to address, and we recognize it. You know, again, I've worked for kind of product companies before where the sensitivity to price of a few dollars or even tens of cents even can be really quite material. So how we get the bill of material costs in a way which sits in the right ballpark is going to be really quite important. Test case coverage. So one of the barriers to adoption is people have confidence that if they deploy it, and we saw this with other memory corruption mitigations at the beginning of the century, developers were reticent to turn them on because they were afraid of their software crashing where it didn't crash before. And because of the, shall we say, the forgiving nature of the architecture as it was, those bugs didn't necessarily always become apparent. But when you turn on, for example, stack corruption detection, things start crashing all the time. You actually have to fix the bugs. So, you know, the lack of test case coverage is going to be one of those barriers that we have to recognize and ultimately overcome if we want. Tooling availability and quality, I think we all recognize that. Again, there's effort coming in from government here to support some of this, but how it should not feel like a regression to kind of work with CHERI technologies. It should feel like you are working with the same quality and availability of technology to do debugging and similar as you are with non-CHERI platforms, but it will be considered a barrier otherwise. So a positive future to aim for. Let's say in 5 years we're here. That would be, I think, a mark of success. So in a world where when people prototype, they just use CHERI cores, because who doesn't? That's definitely something that we want to aim for, but it does suppose that the cores are available. We are able to uplift code to CHERI. We're able to quantify what that uplift will take with efficiency and ease. And that means both kind of actually doing the uplift, but then kind of having confidence that the code will run in the way that we expect and being able to ship it at some pace. And I would suggest that, you know, we can get to a world where to not use CHERI is unavoidable, or is at least seen as negligent, right? And people will go, well, you're a bit of a cowboy. And if we can get there, I think ultimately, we would all recognize that we'll be manifestly better off than we are in 2026 when we have VPN appliances with memory safe issues being exploited by state actors. So, in closing, we do need to quantify what the returns are for the people that integrate and use CHERI as a fundamental technology. We need to be able to evidence that there is no better scaled way, and I underline scaled here, to achieve some of the memory safety challenges and arguably some of the compartmentalization challenges that we face. And then we need to be able to quantify how much this is going to cost to adopt it and find ways to relentlessly reduce that cost if we want to get the scale of adoption that we ultimately want. And so with that, thank you very much. I have 5 minutes. Very happy to take any questions if there are any, but thank you.
microphone for questions.
So you talk about, so Jeremy O'Donoghue from Qualcomm, just to be, so you talk about trying to eliminate security by obscurity, and a very good example that I see, I'm involved with common criteria evaluations, and as you're doubtless aware, you get extra points for secrecy.
Yes.
Is there any plan to address that? Because that sounds like it's an international address problem.
It's wonderful. My predecessor removed us from common criteria as a country. So I think as the UK, our position on this is relatively well known, where we don't see common criteria as benchmark. We've moved to a world of what we call principles-based assurance. So there are a number of principles which we document for systems. A vendor can then make claims against those systems, and then an independent lab can test those claims. And we feel that kind of more Anglo-Saxon outcome-based approach is a better one. But I think your question is well made. I don't have the answer because we're not on common criteria, but we shouldn't, I would suggest, be the way to do it. That's fair, yeah.
Other questions? All good? You're all quiet? Okay, thank you again.
You're very welcome. Thank you. Take care.
Thank you.